All right, this is the next half of 6.1 on solving equations. So the first thing that we're going to do to solve an equation is to replace the variable with the given number to see if it makes a true statement. If it makes a true statement, then it is a solution to the equation. So we're going to do this just like we did when we were evaluating expressions. We're going to write the equation replacing the variable with parentheses, and our hope is that we're going to get 17 when we substitute in the number 3. And so 4 times 3 is 12, plus 5 does equal 17, so we would say, yes, this is a solution. Remember, if you see a negative sign in front of the variable, you want to get in the habit of writing a -1. So we're going to say -1 parentheses for x squared plus 3 parentheses for x plus 6, and our hope is that that equals 5 when we replace the x with a 2. So 2 squared is 4, and 4 times -1 gives me -4. And then if I add 6 and I add 6, that does not equal 5, so that would be not a solution, okay? The next one, we have 3 parentheses for x squared plus 2 parentheses for x, and our hope is that that will equal 40 when we plug in a -4. So -4 squared is 16, and when I multiply 16 by 3, I get 48. And when I take 2 times -4, I get -8, and 48 minus 8 does equal 40, so yes, that would be a solution. Now, when we solve problems, equations, we're actually trying to get the variable all by itself. So what I like to do is I like to read this problem in words and then show you that what we're doing is the reverse process. So to undo addition, we use subtraction. And to undo subtraction, we use addition. We always use the opposite. So what this problem right here says, x minus 8 equals 12, it says start with x, and then we're going to subtract 8, and then we get 12. So to solve it, we do the reverse process. We start with 12, we add 8, and we get 20, okay? So that's what it looks like in words, but mathematically what it's going to look like is here. We want to think of that equal sign as the balance of a scale. And whatever we do to the left side of the balance, we have to do to the right side. So when I see a -8, well, first off, I kind of make myself a T-chart, and I draw a little T right here. So that's my scale. And when I see a -8, I am going to add 8. And what happens is -8 plus 8 makes 0, and that's what I want. And then 12 plus 8 makes 20. And the good thing about equations is that you can always check, because I can take 20 minus 8, and that does give me 12. Okay, so to undo subtraction, you use addition. Now we're going to go to this one, and we're going to undo addition by subtracting 11 from both sides. And then we are going to get 11 minus 11 is 0. And so 19 minus 11 gives me 8. And then I can check 8 plus 11 does give me 19. I'm only going to do 2 of these first equations. The notes are posted and you guys can see the other 2. Now we're going to go into division and multiplication. So to undo multiplication, you use division. And to undo division, you use multiplication, okay? Now this one right here, everybody always tends to give me the wrong answer because they think x divided by 4 is 8, and somebody's going to tell me that it's 2. But 2 divided by 4 does not equal 8. So if I read this problem to you, you would say start with x, because that's always our starting point. You will divide by 4, and you will get 8. So to reverse that process, I'm going to do the opposite. I'm going to start with 8, I'm going to multiply by 4, and I'm going to get 32. And the way it looks mathematically is I'm simply going to write a little 4 on both sides so that that 4 cancels out, and I get 32. And if I check it, 32 divided by 4 does give me 8, okay? Now the other one says, and I know that some of you guys can look at these problems and just give me the answer, but if you don't have steps in mind of how to undo these things, when we get to harder problems, they're going to make it a little bit more challenging, okay? So this one says take 7, multiply it by a number, and you get 35. I know you know that that is 5, but this is what it's going to look, whoops, sorry, not, we're going to divide by 5. That's the answer. We're going to divide by 7. And so 7 divided by 7 is x, and 35 divided by 7 is 5. So I'm going to let those two problems that follow going to be the ones that you do on your own. Now this little saying right here, don't freaking call me after midnight, those letters each represent some sort of operation. The D stands for distribute. Anytime we see parentheses, we're going to remove the parentheses and take care of those first. The F stands for fractions. If we have fractions, we're going to clear those. The C means we're going to collect like terms. The M means we're going to move variables to one side. The A means we're going to undo addition or subtraction. And the M means we're going to undo multiplication or division. Now, not every problem will have all of these steps, okay? So again, if we're writing this in words, we're going to do the reverse, okay? So I'm going to write it out in words and just say, okay, we're going to start with x. We're going to times it by 3. We're going to subtract 5, and we're going to get 28. So to reverse that process, we're going to do the opposite. We're going to start with 28. We're going to add 5, which is 33. We're going to divide by 3, which gives me 11. Okay? So what this looks like is the following. We're going to draw our T balance. We're going to undo addition or subtraction first. So we're going to add 5 to both sides. That goes away, and we get 3x is equal to 33. And then we're going to divide by 3. And so x is equal to 11. Now, it doesn't matter where your variable is. You just have to locate your variable. And if your variable's on one side, you just leave it there and you cover it up. And if you cover it up, you see that we're adding 5 to the next side. So we're going to undo that by subtracting 5. So we're going to make our T. I'm going to subtract 5 first. And that makes 20 is equal to 4x. I want 1x, so I must divide by the number that's with the x. And so that gives me x is equal to 5. Okay? Same idea. Go through. I'm going to add 2 so that I get that goes to 0. 16 plus 2 is 18. Negative 3t, still negative 3t. And then I divide by the negative 3. And so t is equal to negative 6. And you can still check this. Negative 3 times negative 6 minus 2 gives me 18 minus 2, which does equal 16, okay? All right, the next one. Go here, draw your table. I'm going to subtract 8, and that goes away. 4t is equal to negative 20. Just watch your signs. And then divide by 4. And so t is equal to negative 5. Now, on the next one, we have fractions. And so in order to deal with fractions, rather than having to find common denominators, I'm going to clear the fractions by multiplying by the LCD. So to clear fractions, you multiply every term by the LCD, the least common denominator. So in this case, that least common denominator is going to be 12. Now, if you have to write it out, by all means, write it out like this so that you don't forget to multiply everything by that 12. And it doesn't matter the order that you put them in, okay? So this 3 goes into this 12 and leaves 4. And now I have 8x. This 3 goes into this 12 and leaves 4, and 4 times 1 is 4. And this 4 goes into this 12 and leaves 3, and 3 times 3 is 9. Now you have a much nicer equation to look at, and don't think that you're wrong if you get a fraction for an answer. So we're going to subtract 4. So I get 8x is equal to 5. And then I'm going to divide by 8, and so x is equal to 5/8. Now, it is a little bit harder to check it. You could check it, but it's not necessary. So I'm just going to leave it like that. We're going to go to the next problem, and we're going to multiply everything by 6. And then I'm going to do this. 2 goes into 6 and leaves 3. And 3 times 1 times x is 3x. 3 goes into 6 and leaves 2. And 1 times 2 is 2. And 3 goes into 6 and leaves 2. And 2 times 2 is 4. And now I can subtract 2 so that I get 3x is equal to 2. And then I divide by 3. And x is equal to 2/3. All right, the last fraction problem we have, we're going to multiply everything by 12 because the least common denominator is going to be 12. And so I'm actually going to write this one out just so I have a little bit more room. And then I'm going to take this 2, and that leaves 6, so 6y. This 3, that leaves 4, so I have 4. And this 4, and that leaves 3, and I have 3. All right, and then I'm going to subtract 4, and that goes away. 6y is equal to -1, and then I'm going to divide by 6, and so y is equal to -1/6. Now, on the next one, you'll see a couple things that'll start changing. So now we have parentheses, that's one thing, and we also have variables on both sides. So you have to get rid of the parentheses first by doing the distribution. So 6t plus 11 remains 2t plus 12 minus 5. Now I have to recognize that I have like terms on the same side of the equation. So if I have like terms, those need to be simplified. You only undo if you're moving from one side of the equal sign to the other. So 12 minus 5 gets replaced with 7. And now I see that I have 6 t's on the left and I have 6 t's on the right. So I want to move the smaller coefficient. That's going to be the 2, and the way that I move it is by making it go to 0. So positive 2t minus 2t makes it go to 0. 6t minus 2t is 4t, plus 11 is equal to 7. And now I have that two-step equation where I subtract 11, and I get 4t is equal to negative 4, and then I will divide by 4, and so t is equal to negative 1. Now we'll see parentheses on a lot of sides. We might see 2 parentheses, we might see various parentheses, we'll see variables on both sides. We're going to see a lot of steps. The only thing that this problem pretty much doesn't have is fractions. So we're going to distribute first, take care of all these parentheses. So I will get 12n plus 4 is equal to 20n minus 30 plus 9n. Then I'm going to recognize that I have n's on the same side of the equal sign that I must put together. So 20n plus 9n makes 29n minus 30, and then I have the 12n plus 4 over here. I tend to always move the smaller variable. So I'm going to subtract 12n, and that gives me 4 is equal to 17n minus 30. Now I have a home for my variable, so I'm going to add 30. And so then I get 17n is equal to 34, and I'm going to divide by 17. So n comes out to equal 2. Okay, last one of these type, and then we'll look at some special cases. So now I have 4t minus 12 plus 8 on the left, and 8t minus 24 on the right. Collect the like terms. Do not undo if it's on the same side. So negative 12 and positive 8 makes negative 4. I have the 8t minus 24. I'm going to move the 4t over to the right by subtracting. Do not forget to bring that negative sign down in front of the 4. And then I'm going to add 24 to both sides. And that gives me, that goes away. That gives me positive 20 equals 4t, and I divide by 4, and so t is equal to 5. Now we will have 2 cases that are special that result in either no solution or infinite solution, okay? These are called identities and contradictions. So we have to start the problem just like we always would, following the rules. And now I circle that negative sign so that I'm not missing it. So I will get 3x minus 15 plus x plus 12 equals 6x minus 2x minus 4, okay? Now I'm going to collect the 3 x's and the 1x on the left to make 4x, and then I'm going to collect the negative 15 and the positive 12 to make negative 3. On the right-hand side, I have a 6x minus 2x, and that gives me 4x minus 4. Anytime I have the same number of x's on the left and the same number of x's on the right, they will cancel each other out. So now I get this absurd statement that says -3 is equal to -4. And we know that is not true. So there is no solution for this problem. If you get a false statement, such as -3 equal to -4, then we know that's not true, and that means that we will have no solution. On the other hand, if we distribute and we get something that looks like this, 2x plus 8 minus 3x plus 15 is equal to -x plus 23, we will see that 2x's minus 3x's is -x, and 8 and 15 is 23. And now you can see that we have exactly the same thing on the left and exactly the same thing on the right. And so if you recognize we got the same number of x's, those are going to cancel, and then we get a true statement that says that 23 is equal to 23. And so in this one, we will have all real numbers as solutions. And so this is a true statement. 23 does equal 23, and we call this an identity, okay? So you have a contradiction, which means that there's no solution, and then you have an identity, which means that you have all real numbers. And that finishes 6.1.